On your calculator, I want you to enter these two things as two separate problems. First of all, enter in the cube root of 8. We have a template button for that on our calculator, so we know how to do that, hopefully. What do we get for the cube root of 8? 2, yeah. Now, on your calculator, enter in 8 to the 1/3 power. To do that, you're going to type in the 8, and then the caret button that looks like a little triangle up or something. And then if you're on an old calculator, like a TI-83 or something like that, then you're going to want to type parentheses 1 divided by 3. If you're on a new calculator, then when you press the exponent button here, it will automatically put you in the exponent, and it will leave you there until you tell it to get out. So you can just type in 1/3 without the parentheses in that case. Let me show you that here. Here's my calculator. There's some calculus for you. Okay, we have 8 to the, and notice that I'm in the exponent here, so I just type in 1 divided by 3, and I hit enter, and I get 2. So, 8 to the 1/3 power is also 2. Is that a coincidence? Absolutely not. That's right. This section is called Rational Exponents. What does the word rational mean? The word ratio is in rational. A ratio is a fraction. So we're going to be working with exponents that are fractions, like 1/3. So there's been a secret that's been hidden from you ever since you learned about square roots. And you're going to learn it in this section. In this section, we're studying exponents that are fractions. You've actually been studying exponents that are fractions all along in this chapter. I just didn't tell you that you were. So, here's some facts. The cube root of x is equal to x to the 1/3 power. So based on that knowledge, what would you say the fourth root of x is equal to? X to the 1/4 power. Good. And based on that knowledge, what would you say any index, any nth root of x is? X to the 1 over n power. X to the 1/nth power. What about the square root of x? Yes, it's x to the 1/2 power. What's the square root of 64? What is 64 to the 1/2 power? Yep, they're the same thing. The square root and a 1/2 exponent are exactly the same thing. The cube root and a 1/3 exponent are exactly the same thing. Okay? All right. So let's simplify these then. 216 to the 1/3 power is really saying the third root of 216. Do we have a number that times itself 3 times gives me 216? 6. So the answer is 6. And you'd probably type that into your calculator just as quickly as I reasoned my way through that, but that's what that is saying. What about 7 to the 1/2 times 7 to the 1/2? Now don't type this into your calculator. It's 7. How do I know it's 7? Just by looking at it. They don't cancel. We have like bases here, and we're multiplying like bases. When we multiply like bases, what do we do to our exponents? We add them. So I have 1/2 plus 1/2. What's 1/2 plus 1/2? 1. What's 7 to the first power? 7. Go ahead and type it into your calculator. 7 to the 1/2 times 7 to the 1/2. You just get 7. If I switch this back into radical form, this is called exponential form here. If I switch this back to radical form, 7 to the 1/2 is actually the square root of 7 times the square root of 7. What we wind up with is the square root of 7 squared. Square root and square wipe each other out. The math that's actually going on here is you are multiplying like bases, and therefore you add the exponents. When you add the exponents, you get 2 over 2, which reduces down to 1. That is why this math right here that you've been doing has worked, because of this right here. That's to the 1/2 power, yeah. It's a fraction exponent. Okay, now this last one, 5 to the 1/4 power times 125 to the 1/4 power.
5
Did you enter it into your calculator already, so you know it's 5?
It's 5
Oh, that's a lot. That's too much. Okay, stop. So we have a property that says if I have a b to the nth power, then I can kind of send that n in and get a to the n, b to the n. Right? We've worked with that a couple different times. A to the n, b to the n can be rewritten like this. If I have matching exponents and I'm multiplying the bases together, then I can kind of pull that exponent out and rewrite this like this. Notice that I have matching exponents here. 5 to the 1/4 power, 125 to the 1/4 power. So I can rewrite this as 5 times 125 to the 1/4 power. Now what's 5 times 125? 625 to the 1/4 power. Now is there a number that times itself 4 times gives me 625? 25 times 25 is not 625. And that's only twice. 5. 5 times 5 times 5 times 5 is 625. 25 times 25 is 625. But it's 5 times 5 times 5 times 5. So this answer is 5. But that's why the answer is 5. We're using properties of exponents here to simplify this down. If you type this into your calculator, 5 to the 1/4 times 125 to the 1/4, it'll just give you 5 and you won't know why. You need to know why. Because pretty soon we're going to be working with letters, not just numbers. Yeah. This last one, 7 to the 1/2 times 7 to the 1/2, I could pull that 1/2 out since that's both the same exponent. And I'd have 7 times 7 to the 1/2, which is 49 to the 1/2, which just means the square root of 49, which is 7. Here's your rational exponent key concept for the entire section. The nth root of a, if the nth root of a is a real number, m is an integer, and m divided by n is reduced in lowest terms, then a to the 1 over n equals the nth root of a. And a to the m over n, so any fraction, is equal to, the denominator is my index in my root. The numerator is the exponent on the thing inside. Which means that if I have a to the m over n, then I can rewrite this as the nth root of a to the m. Or I could write this as the nth root of a all to the m power. Both of those work. Very important, 2 little things right here. This guy right there is the whole idea behind this section. If m is negative, then that makes a reciprocal here. Remember what negative exponents do. And a cannot equal 0 because we know that we can't take the nth root of 0. Okay? So let's convert this one to radical form. This is exponential form right here. Convert to radical form. So it's going to be some sort of root x to some sort of power. It's the 7th root. The denominator goes there. 7th root. The numerator is attached to the thing inside. That's it. That's the answer. You would have to simplify this if the exponent here is bigger than the index outside. You'd have to simplify it like we've been doing this entire chapter. But if not, then you're done. That's the answer right there. This one's a little bit tougher. It's tougher because of the negative exponent, and it's tougher because of this decimal, and it's tougher because of what happens when you try to convert it. So let's try to convert this thing. What happens first? I want to turn the decimal into a fraction for sure. But with this negative exponent, what happens? It goes in the denominator. So this becomes 1 over y to the positive 3.5. Now, 3.5 doesn't do me any good. I need to turn that into a fraction. What is 3.5 as a fraction? Yeah, it's 7/2. So now we have 1 over y to the 7/2. Now what? No, well, eventually we are going to have to. But it's asking us to convert to radical form. So we want to do what we did here. 1 over. Yes, that is the second root, so the square root of y to the 7th power. We should see two things here that are wrong with what we have right now. It's being rude, and with this square root and this exponent right here, this can be simplified. So we have to simplify this, and then we have to get rid of the root in the denominator. So to simplify this, we need to find the biggest perfect square that goes into y to the 7th power. Y to the 6th times y. So I have 1 over the square root of y to the 6th times y. What does that simplify to? Y to the 3rd times the square root of y. We're almost there. Yes, that's what we have to do to finish the problem, is make a fancy one with the denominator so that the square root in the denominator goes away. So what is my fancy one going to have to be? No, just the square root of y. This thing here is fine. It's the square root of y that is the problem. So I'm going to just multiply by the square root of y, top and bottom. Multiplying across, because that's what you do when you multiply fractions, the numerator is what? Yeah, just the square root of y. The denominator is y cubed times, when we multiply these together, we get just y. So y cubed times y is y to the 4th. Y cubed times y is y to the 4th. And that takes care of all of my issues. I can't reduce this any farther. I don't have any roots in the denominator. I don't have any exponents being written as fractions. I have radical form here. So that's the answer. So converting from rational exponents to radical form can be kind of a process. Just follow all the rules as you go and you'll be fine. Converting to exponential form is usually a lot easier. Let's switch the square root of a to the 5th to exponential form. A to the 5/2. The numerator is the exponent that's on a, and the denominator of my exponent is the index of the root. And how about this last one? No, that's radical form. We want exponential form. B to the 3/5 is the answer. And that's it. You're done. So we're like halfway through the section already. 11 through 33 odd. You guys are capable of doing all those.